Okay guys, so if you're given two vectors in component form or as a linear combination of the standard unit number vectors, unit vectors, you can find the cross product of the two vectors as a determinant. So let's say we have a vector u given as u of u1I as the components as follows. So what we have we have a vector u with the components u1, u2, u3, and of course those are the unit vectors. And then we have a vector v with the components v1, v2, v2, and the components ijk. So actually the cross product is equal to the determinant of this matrix. So how would you how would we construct this matrix? So this matrix, the first row will be, as we can all guess, because remember we're using the first row as pivot. So which means it will just be the first row will consist of the standard unit vectors I, j, and k. The second row will consist of the components of the first one there. So if it was v cross u, our v1, v2, v3, but now it's u cross v, so then it's u1, u2, u3. So we can't put them in any other order. So the first one, then the next one, that's when you put the components v1, v2, v3. So which means now you can it's easier now if you have that using the concept of so we have I, jk, v1, u1, u2, u3. Then we have v1, v2, v3, right? So we're getting the determinant there. Okay, so then like we said, so if now this is our pivot, if that is our pivot, I is our pivot, so we can cancel there, then remain with that. So remember the I will be plus, so plus I, then remember, so we have j, remember, and k, so it's plus, minus, plus. So the first one we put here is u1, it will be, so we cancel that, so we have u2, u3, v2, v3. The same thing, so we have a plus here. Of course, just bring the k here. Then you can wrap the other k there. Okay, so we have that. So then we have so for okay, oh sorry. Okay, so for the j, if we cancel out, so plus the k, then we'll also have another. So if we cancel out for the j, we cancel that, so we remain with u1, u3, v1, v3. Then for the k, if we cancel out that row, so we remain with u1, u2, and v1, v2, v2. Then we can just get the determinant there. Then we'll have our cross product as a vector there. Okay, maybe just to make it more clear, let's consider an example. So we have two vectors, u. Okay, u is equals to 2i plus j plus k. Then we have another vector v, which is minus 4i plus 3j plus k, right? So now we want to find the cross product. Okay, u cross v. So remember by the rule of cross product, so the first row will be I, j, k. The second row will be the components of u, which is 2, 1, and 1. Then the third row will be the components of v, minus 4, 3, and 1. Okay, then of course the first pivot will be positive. So if we cancel that and we cancel that, so remain with the matrix 1, 1, 3, 1. We get the determinant of that. Then the second will be minus j, because remember second pivot is minus, so it's plus, minus, plus. Okay, so then we have we cancel that row for j, and we cancel the column for j, so remember it's 2 1 1, so 2 1 minus 4, another 1. Okay, then the next is the pivot is k plus k, then we'll have that. So if we cancel the row for k and the column for k, so remaining is 2 1 minus 4 1. Okay, so then basically now we can just use the concept of so 1 times 1 cross of diagonals of 2 by 2 matrix, 1 times 1, that's 1, minus 3 times 1, we have a 3 there, so minus j. 2 times 1, get a 2, minus the negative 4 times 1, so we get positive 4, and negative 4 times this negative there, so we get a plus. Okay, plus k. So never forget the roots, the hats there. So 2 times 1, we get a 2, minus then negative. Okay, okay, the k I think is 2 1 negative 4 and 3 there, so that was a mistake. Sorry, 3 there. 2 times that 6, then minus 4 times that, that's a positive 4, that's negative 4, but times the negative to be positive 4. Okay, so then we have now finally our vector, which is 1 minus 3, we get negative 2, so negative 2i. 2 plus 4, we get 6, so minus 6j plus 10k. Okay, so this is u cross v. So the other question was asking us to find v cross what? V cross u. So v cross u, we know, remember we had a property. So v cross u is simple. It's just the negative of what? It's just the negative of u cross v. We had that property we learned last time. So this is gonna give us the negative of that guy there. So we just multiply that guy by negative. So the first component will be positive 2i, second component also be positive, and that component there will be negative. So this is what we get for v cross u. All right, I think that's all for this segment. See you.